So now we're working with inequalities, and what this is called is a quadratic inequality. Now what we already are supposed to know how to do is solve basic linear inequalities. So for example, 2x plus 5 is less than 6. I can solve that by subtracting 5 and then dividing by 2, so x is less than 1/2, and rewrite that in interval notation, so negative infinity to 1/2. Since it's strictly less than and doesn't include it, I would use parentheses. That we already know how to do. But when you get to quadratic, it's different. Now, if you think about what you would do for this problem, if it were equal to 0, you would either factor or use the quadratic formula. Well, that's what we're going to do in this case as well, but it's the step after that that's going to be different than when you work with an equality versus an inequality. So we need to factor 2x squared plus 5x minus 3. And I'm going to use the technique you've seen me use before. I'm going to multiply the 2 and the 3 together, and we're trying to find numbers that multiply to equal that, which is negative 6, and at the same time add to equal 5. There should either be no numbers that do this, which means the problem doesn't factor, or one set of numbers that does this. And the only thing that multiplies to be negative 6 and adds to be positive 5 is a positive 6 and a minus 1. And what I'm going to do is use those two numbers to replace the 5x that's sitting in the center. So I'm going to say 2x squared, and instead of writing plus 5x, I'm going to put plus 6x minus 1x. And notice that still adds to be 5x minus 3, okay? And that is still less than 0. Now, factor by grouping. I'm going to pull out the greatest common factor in this first two, which is 2x. That leaves x plus 3. I also have to pull out what's common to this and be left with x plus 3, so that's a minus 1. And you're left with x plus 3. Still less than 0. So the final step of factoring is to say, okay, the one that matches, which is x plus 3, times what's remaining out front, which is 2x minus 1, less than 0. Now, if this were an equals problem, the next step would be to set each one of these equal to 0. And that step you actually need to do, but you don't set each one of these to less than 0. That's where it's wrong, because that's not a true statement. If you have two things multiplied together to give you something less than 0, that doesn't mean this one's less than 0 and this one's less than 0. Okay? So you have to consider a case-by-case situation, and to do that, what we're going to do is we're going to find out what values equal to 0 on the number line. So I'm going to set x plus 3 equal to 0 and get negative 3. So at negative 3, I'm not going to put that on there yet. I'm going to solve for this one. 2x minus 1 equal to 0 gives me x is 1/2. Okay, so at negative 3, a function is equal to 0, and at positive 1/2, a function is also equal to 0. Okay, now I need to find out along this line what gives me values less than 0. So what I'm going to do is pick test points. Okay. Excuse me, something on the left over here, like for example, negative 4. And I'm going to plug that into my inequality, either my factored one or my original one, to see if it's true or false. The factored one is easier work usually. So negative 4 plus 3 times 2 times negative 4 minus 1. The question is that less than 0? Well, negative 4 plus 3 is negative 1 times 2 times negative 4 is negative 8 minus 9 is negative 9. But that gives you positive 9, and that's false. So I do not shade in this area over here on the left where the negative 4 came from. Now I pick a point between negative 3 and 1/2, for example, 0. Okay? So I do 0 plus 3 times 2 times 0 minus 1. Is that less than 0? That's the question. Well, that's 3 times negative 1. Yes, this negative 3 is less than 0. That's a true statement. So everything in between I could shade, because it would make it true. Then I'm going to check on the right. So a number bigger than 1/2, 1 for example. So I'm checking is 1 plus 3 times 2 times 1 minus 1, is that less than 0? And it's not. Okay, you do the math. That'd be 4 times 1 and 4 times 1 is positive 4. It's not less than 0. It's a false statement, so I do not shade that, which means my final answer is just this interval in the middle, which is -3 to 1/2. Why parentheses? Because it said strictly less than 0, not less than or equal to 0. Okay, and that's why I put open circles right here and right here instead of filled in circles. So let's try another one. So the inequality 2x squared plus 9x plus 4 is greater than or equal to 0. This is also quadratic. So the idea is to attempt to factor it if possible. If it doesn't factor, we would have to use the quadratic formula. Okay, but let's try to factor it. Well, I'm trying to find numbers that multiply to be 8. We see the 2 times the 4, so multiply to equal 8, and at the same time add to equal the number in the middle, which is 9. And there are two numbers that do that. It's 8 and 1. So I'm going to rewrite 9x with 8x and 1x. So I have 2x squared plus 8x plus 1x plus 4 greater than or equal to 0. I factor by grouping. 2x factors out of this and leaves x plus 4. Okay, 1 factors out of my second set, and then that leaves x plus 4. So my final factored version is x plus 4 times 2x plus 1 is greater than or equal to 0. Now some people can do this straight from 2x squared plus 9x plus 4 straight down to this, x plus 4 times 2x plus 1. That's fine. You do not have to use this technique. That's just for the folks that have trouble factoring those trinomials with a leading coefficient that's not 1. Now the next step is to create my number line. Don't go x plus 4 is greater than or equal to 0 and 2x plus 1 is greater than or equal to 0 and solve that. That's not going to work out for you. You just have to do x plus 4 equals 0 to get -4 on your number line, and 2x plus 1 equals 0 to get -1/2 on your number line. Okay, so here's my number line, and again I got -4 and -1/2. Okay, now what's happening at those places? Well, that is where it's equal to 0. Is equal to 0 okay in this problem? Well, it is, because it has a less than or equal to. So I'm going to fill those in. Not an open circle, but filled in. Okay? Which means we'll have a bracket there later. Now, next, I need to test points. So I need to find out some number that lives out here. For example, x is equal to -5. Some number that lives in between -4 and -1/2, like x equals -1, and then some number to the right, x equals 0 will work. You don't have to pick the same numbers as me, as long as you pick a number in here, a number between, and then a number on the right. Now where am I plugging those numbers in? You can plug them into the original problem. If you know you have factored your problem correctly, that's the easiest place to plug it in, into the factored version. So I'm going to plug it into x plus 4 times 2x plus 1. So that's going to be -5 plus 4 times 2 times -5 plus 1. Is that really greater than or equal to 0? That's the question. Now, you can actually do the calculations outright, or you can just say, look, -5 plus 4 is a negative number, right? 2 times -5 is -10 plus 1 is still a negative number. A negative times a negative is equal to a positive. Is a positive greater than or equal to 0? It is. Okay, so I'm going to shade all of that part of the number line in, because no matter what we plug in that area, it's going to be a true statement. Now let's plug in -1. So I'm going to say -1 plus 4 times 2 times -1 plus 1. Is that greater than or equal to 0? That's the question. The -1 plus 4, everybody agrees, is a positive number. 2 times -1 plus 1 is actually a negative number. Now, a positive number times a negative number is always negative. Is a negative greater than or equal to 0? And no, that's a false statement, right? So I do not shade in anything on that part. And then I go to x equals 0. So it'd be 0 plus 4 times 2 times 0 plus 1. Now 0 plus 4 is positive, times 2 times 0 plus 1 is positive. Positive times positive always equals a positive. Is that greater than or equal to 0? Yes, that's a true statement. So I shade in this particular part of the number line, and then I write my final answer in interval notation. So my answer is going to be -infinity to -4 with a bracket, because that's a filled in and that's an equal to. So bracket union, bracket again, negative 1/2 to infinity. And this is the answer that I'm looking for. Okay, next problem. We have, it's not quadratic because it's a degree 3. It's x to the 3rd. But this looks a little different than our others as well. You notice our last two problems, this had a 0 on one side. And the goal for all of these is to attempt to factor. Well, if you factor, you need a 0 on one side. You're not going to get anywhere. The factoring technique's not going to help you out if you don't have a 0. So the first thing I'm going to do is subtract 3x from both sides of this inequality, which I'm totally allowed to do, and get this thing with a 0 on one side. So this is what I'm doing, okay? I'm also getting rid of this where my hand was sitting. Okay, so I've got x to the 3rd plus 2x squared minus 3x is greater than 0 over there. Then I factor. Notice there's an x common to all three of those terms. Greatest common factor coming out. So x comes out, that leaves x squared plus 2x minus 3, still greater than 0. This is a trinomial, which I can factor. We're trying to find numbers that multiply to be negative 3 and add to be 2. I don't have to do that factor by grouping technique for these because the leading coefficient is 1. So I can just write it down immediately. And again, those two numbers are, well, x goes in the first spots, but the two numbers are plus 3 and minus 1. Again, check it. X times x is x squared. X times negative 1 is negative x. But plus 3x gives me 2x, and 3 times negative 1 is negative 3. So we have factored this correctly. Now, in terms of what goes on my number line, I'm going to have, there's 3 different things I'm setting equal to 0. Like this first guy right here, I set him equal to 0. And then I set x plus 3 equal to 0. And I set x minus 1 equal to 0. So that's one of my results. Negative 3 is another one. And 1 is the last one. Now remember, these aren't my answers. These are values that go on the number line that split my number line up. In order, I've got negative 3, and then 0, and then 1. Now what's going on with these? Well, strictly greater than 0 means these points are not included. There's an open circle there, there, and there. Now what we've got to find out is, in between all of these open circles, do we shade or do we not shade? So I have to test points. Like I'm going to pick, for example, x equals negative 4 as a test point because it's to the left of negative 3. Something between negative 3 and 0 might be x equals negative 1. Something between 0 and 1 would be x is equal to 0.5 or 1/2. And something bigger than 1 would be 2. So I have to test something in all 4 of those pieces. So I'm taking my negative 4 and I'm plugging it in either my original inequality, but this would be easier, the factored version. So it's going to be negative 4 times negative 4 plus 3 is negative 1 times negative 4 minus 1 is negative 5. Okay? Now, is that greater than 0? That's the question. Well, no, it's not, because a negative times a negative times a negative is a negative, and negatives are not greater than 0. So this piece is out. That is not part of our answer. Now I'm going to plug in negative 1, again, into this factored version. So that's going to say negative 1 for the x, negative 1 plus 3 is 2, and then negative 1 minus 1 is negative 2. Question is, again, is that greater than 0? Well, it is, because negative 1 times 2 is negative 2 times negative 2 is 4, is greater than 0. That's true. If it's a true statement, then I shade that part of the number line in. Okay? Now, something between 0 and 1 was 0.5. So here we go. I'm going to say for my x value, I'm in back over here, my x value is 0.5. In my next factor, I'm doing 0.5 plus 3, which is 3.5. 0.5 minus 1 is negative 0.5. And the question is that greater than 0? Well, it's not, because we're doing a positive times a negative, which is a negative. Is negative greater than 0? No, that's a false statement. So this little piece is out. That is not in our number line. Okay, not in our answer. It's in our number line, but it's not in our answer. And then I plug in 2. So I'm plugging in 2 for that first factor, which is x. 2 plus 3 is 5 for my second factor, and 2 minus 1 is 1 for my third factor. Is that answer greater than 0? And it is. It's 10 is greater than 0. That's true. So I shade this piece in. And my final answer is what is shaded. Again, these numbers that divide our number line up into these sections, those are not included because it says strictly greater than 0, and in the beginning strictly greater than 3x. So there's parentheses, so I'm going from -3 with a parenthesis to 0, and then union 1 with a parenthesis to infinity. And there we go. Final answer. All right, so we have another inequality. Now this is called a rational inequality, and the tricks are the same as for quadratic inequalities or what we call higher order inequalities, degree 2 or higher. Your goal is to get a 0 on one side of the inequality, and we already have that in this case. The next step is you put your number line down, and what goes on the number line are those values again that would make this equal to 0. So I'm going to set x minus 6 equal to 0, and I get x equals 6. So that's got to go on my number line. And I set x plus 2 equal to 0. That gives me x is equal to -2, and that's going to go on my number line as well. Okay, so I put -2 on my number line and 6 on my number line. And remind myself, is it filled in or is it not filled in? Now, -2 cannot be filled in because that makes the denominator 0. So anytime a denominator gives you one of your values, that's got to be open. Okay, not filled in. Always open because it's from a denominator. Okay, so always open there. Now, this one could be filled in if it had a greater than or equal to, but since it's just a greater than, it's open as well. Okay, then we do the same thing we did earlier, is we pick points or pick values in between and outside of all of these. So I'm going to test points, like for example, -3 would be something from the left side. A point in the middle would be x equals 0. And then a point on the other side might be x equals 7. And so I'm going to plug that, excuse me, I'm going to plug that into my original inequality over here. If the inequality needed to be factored or something, plugging it in the factored one would be the way to go. This is already factored, so we don't need to do that. So I'm going to do -3 minus 6 in the numerator over -3 plus 2 in the denominator. We're trying to see, is that true or false? Is that greater than 0 or is it not? In the numerator, notice we have a negative. -3 minus 6 is a negative. In the denominator, we also have a negative. A negative divided by a negative is equal to a positive. And is a positive greater than 0? That's the question. And yes, that's true. So I shade in this side over here to the left because this would be true for every value you plugged in, not just -3. Okay? Then I plug in 0, I do the same thing. So 0 minus 6 in the numerator, 0 plus 2 in the denominator, and that gives me a negative number in the numerator divided by a positive number in the denominator. A negative divided by a positive is always equal to a negative. Is a negative greater than 0? No, not ever. So that means this value is out. 0 did not work out for us. Okay, then I plug in 7. 7 minus 6 divided by 7 plus 2. 7 subtract 6 is 1. 7 plus 2 is 9. Is 1/9 greater than 0? Yes, that's true. Or is a positive greater than 0? I didn't do it like I did the other two, but it's still true. So I shade everything in that interval because all those numbers, not just 7, but 7, 8, 9, 10, and any real number past 6 will make that true. Okay, so I write my answer in interval notation. So this number line is not my answer, but it helps me write it. So I'm going from -infinity with a parenthesis, because infinities always have parentheses, to -2. The -2 is not included because it came from a denominator. Okay, denominators are never included. You'll never have a bracket around a denominator number. Union, Now 6 is not included because of the greater than. There's no equal to there, therefore the 6 is not included to infinity, and this is the final result. Alright, so we have another rational inequality. Things that you have to know for these inequalities, all of them, is you need a 0 on one side, and then you need a factor, and you set each factor equal to 0 to figure out what goes on your number line. Okay, so we've got the 0 on the right hand side, so that's a good start. This problem is also already factored for you, so the second thing has been done. Now we just need to figure out what numbers go on our number line. And to do that, you set each one of these three factors equal to 0. So you set x plus 1 equal to 0, and that gives me negative 1. Okay, so negative 1 is going to go on my number line. I'm going to circle it only just to remind me to put it on my number line. X minus 2 equal to 0 gives me x is equal to 2, goes on my number line. And then the denominator. Okay, so your denominator of x minus 1 equals to 0, x equals 1 goes on the number line. But remember, this has always got to be an open circle, no matter what, because it came from a denominator. So let's put all these on our number line. The smallest of them is negative 1. Next in line is positive 1, and then 2. Okay, now remember, at 1, it's definitely an open circle, no matter what, because it came from a denominator. But now negative 1 and 2 came from a numerator, and it matches whatever the inequality says. And it's got an equal to, which means these can be filled in. Okay, so denominators are always open, no matter what the original problem says. Factors that come from the numerator match whatever the inequality says. If there's an equal to, it's filled in. If there is no equal to, then it's open. Okay, now we need to test points. So some good points to test, something out here. So for example, maybe x equals negative 2. Something between negative 1 and 1, so maybe x equals 0. Something between 1 and 2, maybe 1.5. And then something bigger than 2, for example, 3. I'm plugging those into my factored inequality, so it's going to be negative 2 plus 1 times negative 2 minus 2 divided by negative 2 minus 1. And we're just trying to check, is that a true or false statement? Okay, now one thing I can do here is I can say negative 2 plus 1 is a negative number, right? Negative 2 minus 2 is a negative number. I didn't need to put that 1 in there. Right back over here, that 1 does not belong. All I wanted was just the negative symbol. So negative, negative, and the denominator is also negative. Now a negative times a negative is a negative in the positive in the numerator divided by a negative in the denominator. Overall, this is negative. Is a negative number greater than or equal to 0? And that's no, that's false. So negative 2 is out. That interval is out. It's not part of our answer. Now a number between negative 1 and 1 was 0. So let's just do this again. You got 0 plus 1 times 0 minus 2 divided by 0 minus 1. Now, you can actually do this calculation, okay, or you can do like I did a minute ago. 0 plus 1 is a positive number. 0 minus 2 is a negative number. 0 minus 1 is a negative number, okay? Overall, that answer is positive, right? Because these two negatives cancel to give you a positive, and a positive is greater than or equal to 0. That's a true statement. So that means everything between negative 1 and 1 needs to be shaded. Okay, now I'm going to check between 1 and 2. So I have 1.5 plus 1 times 1.5 minus 2 divided by 1.5 minus 1. 1.5 plus 1 is positive, 1.5 minus 2 is negative, and 1.5 minus 1 is positive. Overall, that's a negative answer. Is negative greater than or equal to 0? No, it's not. Okay, so this is a false statement. 1.5 is out, and that interval is out. And then finally, we'll plug in 3 to check this interval on the right. So 3 plus 1 times 3 minus 2 divided by 3 minus 1. 3 plus 1 is a positive number. 3 minus 2 is a positive number as well. Denominator is also positive. All that's positive, which is greater than or equal to 0. So this is included in our answer. So our final answer, let's do this in green, is going to be interval notation included. So I need a bracket, negative 1, to 1 with a parenthesis, because remember that came from the denominator, union, and now it picks back up in purple right here at 2 with a bracket all the way to infinity. So the green is our answer again. Negative 1 with a bracket because it's included, all the way to 1 with a parenthesis because that came from the denominator. That picked back up at 2 with a bracket because it's included, all the way to infinity with a parenthesis because infinity always has parentheses. Okay, another rational inequality. Now the first thing is we always need 0 on one side of this inequality, and we do not have that in this case. So what I'm going to do is I'm going to subtract 5 from both sides to get this thing with a 0 on one side. The problem is that's not all we're going to have to do. So I'm going to have x plus 3 divided by x minus 4 minus 5. Now that's less than or equal to 0. Our next problem is this is not one fraction. Okay, we really need this to be one fraction over here on the left so we can do the analysis that we've been doing. So we have to find a common denominator, which is x minus 4. So here's what I've got to do. I've got to multiply this by x minus 4 and this by x minus 4. So it's going to be a little bit of work. So I've got x plus 3 over x minus 4. Then I'm going to distribute this negative 5 inside. So minus, let's leave the minus out for now. I'm just going to do just this, okay? So 5x minus 20 over x minus 4. Remember, less than or equal to 0. I'm still trying to combine this together. So now it's going to be one fraction over my common x minus 4. Now, like terms, so x and a minus 5x is going to give me negative 4x. Okay? 3 plus 20, because this negative has to distribute inside. Okay? So 3 plus 20 is plus 23. Now, this is my inequality that I'm putting on the number line. Okay? So I set negative 4x plus 23 equal to 0 to figure out what number to put on there. So I subtract the 23. And I divide by negative 4. So that's going to be 23/4. Now if you like, that's 5 and 3/4, written as a mixed number. So that's going to be one of my numbers that goes on the number line. The other one is just x minus 4 equal to 0 gives me x equals 4. Okay, so I have 4 on my number line and 5 and 3/4. Or you could write it as 23/4 if you like. Alright, now, next problem is figuring out, is it an open circle or is it a closed circle? If it comes from a denominator, it's an open circle no matter what. So there's an open circle there. If it's a numerator, it's based on what your inequality is. If there's an equal to, it's filled in, like in our case. If there was no equal to there, then it would be an open circle. Okay, hard part's over. That was it. Now we just test some points. So I need to pick a point out here less than 4 to test. I'm going to test x equals 0. I need to pick a point between 4 and 5 and 3/4. Let's pick x equals 5. And then a point bigger than 5 and 3/4, like x equals 6 or 7. I'm just going to do 6. So I'm going to plug 0 into. Now, I could go to my original inequality, but I think it would be easier to use this one that I've purpled off right here. Because it's got the 0 on the other side and the analysis will be easier, but you could always go back to the original and work it all the way out and see if that's a true or false statement. So I've got negative 4 times 0 plus 23 divided by 0 minus 4. If I simplify that, that just gives me a positive number over a negative number. Not negative 1, again, a negative number. And a positive divided by negative is always equal to a negative. And that is less than or equal to 0. That's true, right? Okay, so this needs to be filled in. Now I'm going to check a number between 4 and 5 and 3/4, and 5 was the winner. So negative 4 times 5 plus 23 divided by negative 4 minus 4. That gives me a negative in the denominator and a positive in the numerator. That's equal to a negative number, which is less than or equal to 0. That's a true statement. Okay, and then I plug in 6. So negative 4 times 6 plus 23 overall that gives me a negative number, and then 6, I'm sorry, minus 4 is positive 2, and negative divided by a positive is a negative. Is that less than or equal to 0? That's also a true statement. I got to looking at this problem a little bit better. I felt like something had to be wrong with them all shaded in. There are problems that do that, by the way, but I didn't feel like this was one of them. And I went back and looked at my work, and I did find my mistake. You've probably already seen it, but right here, that was supposed to be a 5 plugged in. So that should be 5 minus 4, which is a positive. A positive divided by a positive is a positive, which is not less than or equal to 0. That's a false statement. So I need to go back and fix my number line right here. Okay, and draw that back in there. There we go. And this is not shaded, okay, because, and again, I just copied that negative 4 probably from, I'm just not thinking, but that'd be 5 minus 4 is positive. And so my final answer is the shaded part. So we're talking negative infinity to 4, sorry about that, with a parenthesis, union, bracket, 5 3/4, or 23/4, whatever you want to use, to infinity. The final result there. Alright, so we have 3 more of these inequality problems. I'm not going to bother making another video. This is just going to be a long one. So we're supposed to factor, if possible, and you're supposed to have 0 on one side. Notice there's a 0 over there, so that's good. This does factor numbers that multiply to be 1 and add to be 2. So this is x plus 1 times x plus 1 less than 0. Okay? So we have to figure out what goes on our number line. And it's going to be these factors set equal to 0. Now you certainly don't have to do it twice because it's going to give you negative 1 both times. So negative 1 is actually the only value that goes on our number line. Next question is my circle filled in or is it open? Well, it didn't come from a denominator. That's not why it's open. It's because there's no equal to right here, and so it's going to be open. Now I just need to test points. So I need a point on the left of negative 1, say for example x equals negative 2, and a point on the right of negative 1, say for example x equals 0. I plug it into either the factored or the original one. I always like the factored one with the 0 on the other side, and so that's going to be negative 2 plus 1 times negative 2 plus 1. Question is that less than 0? Well, negative 2 plus 1 is negative 1, right, or a negative number. Negative 2 plus 1 is negative 1, or a negative number. A negative times a negative is a positive, and 1 is not less than 0. This is a false statement, so we don't include this part. Then I check 0, okay? So 0 plus 1 times 0 plus 1. Question is that less than 0? Well, 0 plus 1 is 1 times 1, or a positive times a positive, less than 0. That's 1 less than 0. Nope, that's a false statement as well. So we don't include that either. And this was open. We don't include that. So what does that mean our answer is? Well, nothing. This has no solution. There are no numbers, period, that make that inequality true. It's impossible. Okay, so this problem looks identical to the last problem, right? Except I put an equal to in there. So the story is the same. We need to factor. So it's x plus 1 times x plus 1 less than or equal to 0. I set each of these factors equal to 0. I don't have to do it twice, so I get x equals negative 1, and that's only to figure out what goes on my number line. Okay, now, the next thing is this an open circle or a closed circle on top of negative 1? And it's a closed filled-in circle because of the equal to right there. So whenever it's equal to, and your value comes from a numerator, which both these came from the numerator, then it's included. Now you test a point. Okay, so again, same story. We would test negative 2 and maybe 0 or 1, whatever you want, and plug that into the factored version. So negative 2 plus 1 times negative 2 plus 1, is that less than or equal to 0? And that's negative 1 times negative 1 less than or equal to 0. That's false. 1 is not less than or equal to 0. Okay, so we don't shade in that part. Then I check 0. 0 plus 1 times 0 plus 1. Is that less than or equal to 0? Well, no, because that's 1 less than or equal to 0. Again, it's false. Oh, no, that doesn't like false. It says false. So that's not included either. But this is not the same as the last problem because this point is included. We only have one number in our answer, and that's when we use those curly brackets just to denote a list of numbers, not an interval. Okay, so that's our final answer there. Okay, so the last problem in our review is x squared over x squared plus 16. Greater than 0, so good news. We do have a 0 on one side, so we don't have to do any moving terms to the other side and finding a brand new common denominator or anything like that. We do need to factor if possible. Well, x squared plus 16 doesn't factor. So now we just set what we have to equal to 0. We need to figure out how to break up our number line. Okay, so I set x squared to equal to 0, and I set x squared plus 16 equal to 0. Well, x squared equals 0. I take the square root of both sides, and I get plus or minus the square root of 0, which is just 0. So that's going to go on my number line. I subtract the 16 over, because this wouldn't factor, and this is a way to solve. Take the square root of both sides, and I get imaginary numbers. Okay, right? Imaginary numbers do not go on a number line. Number lines are just for real numbers only. So this didn't give us any real value solution. So the only thing that goes on my number line is 0. Okay. Now, for 0, is it filled in or not? Now, it didn't come from the denominator, so I don't have that concern. But there's no equal to here. So that means it's open at 0. Now I pick test points. So I need to pick something on the left of 0, like x equals -1, and something on the right of 0, like x equals +1, and plug it in my inequality. So I've got -1 squared over -1 squared plus 16. Is that greater than 0? It is, because that gives you 1 over 17, and 1 over 17 is greater than 0. So where the -1 came from is the left side of my number line, so I shade that in. And then I check +1, okay? So that's 1 squared over 1 squared plus 16. We're trying to see, is that greater than 0? Well, I get 1 over 17 again, and yes, that's still greater than 0. So I shade this side. And then when I write my final answer down in interval notation, we're talking -infinity to 0, and then union 0 to infinity. So basically, every single number makes this inequality true except the number 0. 0 makes it equal to 0, and 0 is not greater than 0. And that's it.